Yeah, in this video, I'm going to discuss about the Lewis dot structures of few of the compounds following the simple techniques which you can write easily. So yeah, let's look at this Lewis dot structures of CO3 2 minus and PO4 3 minus in this particular video. Yes, carbonate ion and phosphate ion. So So I've already dealt with this in my previous video, how to write the Lewis dot structures following the simple techniques. Yeah, I once again a little review of that first before counting the, writing the Lewis dot structures of this. Let's find out the simple things like this. First is count the total number of the valence electrons in that particular compound. So this total number of valence electrons is carbon. We know that its atomic number is 6. So its electronic configuration is 1s2, 2s2, and 2p2. So outermost electronic configuration is 4 here, and for oxygen it is 8. So 1s2, 2s2, and 2p4. Its outermost electronic configuration is 6 here. So total number of valence electrons in this is equal to 1 into 6, that is only 1 carbon, plus 3 into 6, this is 4, I'm sorry, yeah. 1 into 4. So two more electrons because it is -2. So this is 4 plus 6 3 are 18 plus 2. The total number of we have the electrons in this is 24 electrons. So 18, 19, 20. Yeah, 24 electrons. So now write the structure with then select the central atom. The central atom is carbon here because only one in number. And after writing the central atom, then put the terminal atoms towards the corners of this and write single bond in between all these. So now the bond pair of electrons will be 3 bonds with each have 2 electrons, so 6 electrons. Now count the lone pair of electrons, which is equal to valence electrons minus the bond pair of electrons, which will be 24 minus 6 is equal to 18 electrons. Now where do you put this 18 electrons now? First start this 18 electrons, putting them as lone pairs. Yeah, lone pairs. So 1 2 3 4 5 6 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, okay. 18 electrons we have got this lone pairs. So now count, count this number of electrons in each of these atoms, whether the octet is complete or not. So let's see for this oxygen atom, whether the octet is complete for this. Yes, 1, 2, 3, 4, 5, 6, 7, 8. So yes, whether the octet is complete for this, yes, it has 8 electrons, and also this has 8 electrons. Now coming to the central atom, that is carbon, whether the octet is complete for this, no, because 1, 2, 3, 4, 5, 6. So what do you do in order to complete the octet? So the central atom may have as minimum of 8 electrons or more, but not less than this. So what do you do? So now shift this lone pairs to the bond pair. So one of the electrons you can shift here. So this lone pairs now can be used as lone pairs or converted into double bond or triple bond if needed. So the structure of this can be now be modified as this is O, double bond O and O. Yes. Right. So the octet is complete now for the central carbon atom. So this is 1, 2, 3, 4, 5, 6, 7, 8, done. So is the structure complete now? No, because you need to write this negative charge also. So where do you write this negative charges? In order to count the negative charge now, so first we should calculate the formal charge on each of these uh, atoms or ions. So how do you calculate this formal charge? So next go to the next slide and look at how to calculate this formal charges on each of these. So the ion we have taken is CO3 2 minus. Now we arrived at this particular structure. So this is double bond O, O and O, and this has 3 lone pairs of electrons, and this has only 2, and this has 3 lone pairs of electrons. Now where do you put these two negative charges? So the formula to calculate the formal charge is valence electrons on that particular atom minus the lone pair of electrons on that particular and the bond pair of electrons by 2. So when you number this, okay, this is 1, 2, 3 and 4. So if you take this Roman number 1, oxygen, so the valence electrons is 6 minus lone pairs is 1, 2, 3, 4, 5, 6, and bond pairs is only 1. So it is 2 electrons by 2 will get minus 1. So the formal charge on this is 1. So this is minus 1. So now let's calculate the oxygen. So this is the same for 1 and 2, right? So same type of oxygen. So here also you'll get minus 1. So here it is minus 1, right? So now for type 2, type 3 now. So how many valence electrons? Again, the same thing. How many lone pairs of electrons? Only 2 lone pairs. That means totally 4. How many bond pairs are there? 1, 2, 3, 4. Yeah, 4 by 4, right? 4 by 2. So this will be 0. So the formal charge on this oxygen is 0. What about this carbon atom now of type 4? This carbon atom, let's calculate it. So valency is 4 here. You know that carbon valency is 4. No valence electrons, so minus 0. And so how many bond pairs are there? 1, 2, 3, 4. So 8, right? So minus 8 by 2. So the formal charge on this carbon is also 0. So now calculating these formal charges, we arrived at this particular structure of this Lewis dot structure. So this is the Lewis dot structure. This 3 lone pairs of electrons on this oxygen atom, 3 lone pairs of electrons on this oxygen atom with a negative charge, and this negative charge here only 2 lone pairs. This is the structure of CO3 2 minus. That's the Lewis dot structure. Now look at this. Now look at this, the structure of I mean PO4 3 minus, that is the phosphate ion. Yes, 3 minus. Again, before writing, now try writing the structure. The total number of valence electrons on this will be, so phosphorus is yeah, phosphorus is, we know that for phosphorus the atomic number will be 15. So it is 2, 8 and 5. So valence electrons are 5. And for oxygen, we know this is 8. So this is 2 and 6, 6. So total number of valence electrons on this will be 5, plus how many oxygens are there? 4 into 6, plus 3 electrons, because the charge on this is 3. So add 3 electrons to this. 6 4s are 24, 29, and the total number of valence electrons is 32 electrons in this. So now, right, what is the central atom in this? It's P, because the least in number, only 1. So write oxygens, that is the terminal atoms, on all the sides of this. Now put one bond, or a single bond, to all these connecting P. So the bond pair of electrons will be now 30. I mean, sorry, this is Let's erase this. So yeah, now it will be easy for us. Yeah. Now the bond pair of electrons will be 2 into 4 because 4 bonds, that's 8 electrons. The remaining are lone pairs, that it is 32 minus 8 valence electrons minus the bond pair of electrons, which will be 24 electrons. So these can be used in lone pairs or double bonds or triple bonds if needed. So try writing this lone pair of electrons on the terminal atoms first and then go to the central atom if there are any left. So 16, 18, 20, 24, 30. So these are 6 fours are 24 electrons. So all these 24 electrons we have written on the terminal atom. So now let's see whether its octet is complete or not for all these. Yeah. So yeah, this is 8. Okay, this is also 8, 8, 8. So central atom phosphorus is also having 8 electrons. I agree with this. But what is the covalency of phosphorus? So it should have 5 pairs of electrons totally. So, but it has only 4 pairs of electrons, but its not covalency is not satisfied, and there is no lone pair also. So, shift one of the lone pairs on the oxygen atom towards the has a double bond here. So now the structure can be rewritten as oxygen. Yeah. Now, where are the formal charges should be written now? So I mean the three negative charges can be written. I mean calculate the formal charges on each of these oxygen atoms now. So these are of one type. All of these are of the same type, and this is of two type of oxygen, and this is the third one, that is the phosphorus. So of one type of oxygen, let's calculate the formal charge for this. So formal charge is nothing but the valence electrons on that particular atom minus the lone pairs of that particular minus bond pairs divided by 2 here. Bond pairs by 2 here. So the formal charge on, if you how do you calculate this? The valence electrons of this is, you know, that it is 6 minus lone pairs are again 6 here, minus bond pairs are 1 bond, so 2 electrons by 2. So this, if you calculate, this will be minus 1. So 1 of all these oxygens will be, the formal charge will be minus 1. So minus 1, this is also minus 1, this is also minus 1. Yes. Yes. So minus 1, minus 1, minus 1. What about this oxygen of type 2? Let's calculate the number of valence electrons. So how do you get the formal charges? The valence electrons on this is 6, you know that. And so lone pairs are 4 and bond pairs are again, 4 by 2. So if you calculate, it is 0. The formal charge on this oxygen is 0. And then now let's come to the phosphorus. The valence electrons are 5. I minus no lone pairs, and the bond pairs are 1, 2, 3, 4, 5. So 10 by 2. So again 0. The formal charge on the phosphorus is also 0. So this is the Lewis dot structure of phosphorus. I mean the phosphate ion. So I'll rewrite this again for your convenience on yes. So the phosphate is, I'll write here P O O O O. One is a double bond with 2 lone pairs, and others are having the charge of 1 with 3 lone pairs here on each of these oxygen atoms. So this is the Lewis dot structure of PO4 3 minus. So this is PO4 3 minus, and for CO3 2 minus, let's write it again. So all oxygens, and we have one double bond and three lone pairs on this, and also three lone pairs on this, and one negative charge and one negative charge. So these are the Lewis dot structures of CO3 2 minus and PO4 3 minus. So following the simple rules, we can write the Lewis dot structures very easily. So I've discussed few of these in my other videos also. So if you like them, please do like, share, and subscribe my channel. And the whole chapter of this, that is a chemical bonding, chapter 10 of degree first semester, has been discussed on my YouTube channel, and the details of this have been given in the description box below.